Hello. All right, let's get going. Number. Start the timer. Number 161. One edit distance premium. Medium. Given two strings S and T, return true if they are both one edit distance apart, otherwise return false. A string S is said to be one distance apart from a string T if you can insert exactly one character into S to get T, delete exactly one character from S to get T, or replace exactly one character of S with a different character to get T. We can insert C into S to get T. Okay. All right, given two strings, return true if they are one edit distance apart, return false otherwise. So we can just check for each location in S, we can check if editing or we can check if inserting would help. We could check if deleting would help, and we could check if replacing would help. How would we know which character to insert? I guess we would just look at that index in string T. So that would just take O of n time, where n is the number of characters in S. There's n things. There's n times 3 things to try. So I think that'll work, and that should be optimal because you can't do better than you have to at least look at every character in S. It's just that. Yeah. No. Technically, that would be O of n squared. Because then after each check, I have to check if S and T are equal. But I can speed that up by checking if S and T are equal along the way. So it's kind of like a two-pointer solution, except there's only one pointer and it's the index into S. So it looks like this. For I in range len of S, so for each index into the string, if S of I equals T of I, then you don't need to do anything. Already equal. Elif or else. Then you can try inserting, deleting, or replacing. So insert, delete, replace. So actually, we can think of this as a two-pointer thing where insert, delete, and we don't actually have to do the insertion, the deletion, and the replacement. We can just like pretend that this character is not a problem anymore and move on to the next one. So depending on whether you do an insert or a delete or a replace, it changes which of the indexes you move forward. So let's say I and j equals 0 and 0. You start at the same place while I is less than length of S. If the two characters are equal, then S of I into T of j. So we always index I into S and j into T. If they're equal, then you can increment both. I plus equals 1, j plus equals 1. If they're not equal, but actually, even if they're equal, you might want to do this. All right, the thing I'm just realizing is that there's not a unique thing that you would want to do at this point. You might want to try deleting and try inserting and then see what that does. So maybe this two, I guess you could just figure out which one is the right one to do and only consider that one. If the edit distance is 1, then we can actually tell which one it is based on the length of the strings. If they're the same length, then we need to do a replace. If they're off by 1, we either need to do insert or delete, depending which one's larger. So there is actually a unique thing to try. Yeah. Okay, so how do I say this? So if they're the same, increment both. If len of s is less than len of t, that means we're going to want to do an insertion. So the first time that the characters are different, increment I, or actually don't increment I, do increment j. This is saying I've just added a letter to S that you didn't see. Which made it equal to T. And now we're moving on to the next letter. We have to make sure that we've only edited once. Edits equals 0. Edits plus equals 1. So if not edits and insertion is the kind of edit you're allowed to do, then do this. Elif not edits and if they're equal, then the kind of edit you're allowed to do is a replacement. Which would mean increment I, but not j. So this is saying no, you know what? If it's a replacement, you increment both. So you've got a string ABC A6C. I and J are both on the second character here. And they don't equal, but I'm saying, don't worry, bro. That one's a B now. So now you increment both. Okay. Then the third type of edit you might want to do, if not edits and len of S is greater than len of T, that means you're allowed to do a deletion. So this is S, this is T. A and A are equal, we increment both. B and C are not equal, so we're going to delete. So deleting this is the same as incrementing I by 1. I plus equals 1, edits plus equals 1. Then at the end, you return edits equals 1. So if you only had to do one edit, you win. Submit. If there is no T of J, I think that counts as they're not equal. So if I is less than len of S and J is less than len of T, and they're equal, too slow? Timeout? It's taking a long time. No, just wrong answer. So here S is smaller than T, and we said false. So I guess we never do anything because how do we handle this? We already started at the end of I. I think I should say while I is less than S or J is less than len of T. Because T wasn't at the end yet, only I was at the end. Okay. Time limit exceeded. Oh, you know what? Because I'm not saying what to do if you do have edits and you're not equal. But the answer is you return false. You can't differ in more than one place and still count. Which means I don't think I actually have to return edits equals 1 here. I guess I do, because edits might be 0 and we would still get to the end. Is there anything we can do to get that sweet, sweet 0 millisecond runtime? So we already exit early. If ever you want to do more than one edit. I guess we could exit early if we're off by more than one. So if abs of len of s minus len of t is greater or equal to 2, you return false. That's just a little shortcut. That makes it slower. Interesting. Okay, well there's no point in complicating it with a shortcut if it's not going to make it faster. Edits could be a Boolean. That's not going to make a speed difference either. Yeah, I don't know. It seems as fast as you can make it. How do people make it faster? Beats 100%. How did you do it? So you have 2 indexes. You're cheating here. I mean, like, you're not exactly cheating, but this already takes O of n. So, like, algorithmically, you're already as slow as I am before we get to the real algorithm. Keep looking for the first mismatched characters. So, while you can keep going, that's also what my while loop looks like, and they are equal, then you increment both. That is what I'm doing. And then you simply... Oh, so maybe this slicing is optimized in Python, so it can quickly... I mean, it probably is, because the thing about Python is in order to increase the performance, you have to do less stuff in Python. Even if what you're doing is algorithmically worse, if you're doing it not in Python, it'll be faster. So if you just tell Python, compare slices, then it can say gotcha and go to its C implementation and do that really quickly. Even if you had an algorithm that does character by character but faster, it'll be slower because it's doing it in Python. So next problem, number 162, find peak element, medium. A peak element is an element that is strictly greater than its neighbors. Given a 0 indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 equals nums of n equals negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in O of log n time. Okay, so we're looking for a local maximum. Here's a very obvious O of n algorithm. It's iterate over the numbers until you find one that's larger than its neighbors. We want to do O of log n, so I'm thinking we want to do some kind of binary search. The problem is it's not a sorted array, right? A peak element given a 0 indexed integer array is not sorted. If it's not sorted, how can you necessarily do better than iterating over the elements? I guess the idea is trying to think of how would you make the worst input for your algorithm. So if my algorithm is look at the next thing and the next thing and the next thing until you find something that's greater than its neighbors, then the worst input would be one that's sorted and strictly increasing, because then I would have to go through the whole list until I get to the end. But if I run two algorithms at the same time, one that starts at the beginning and moves right, and one that starts at the end and moves left, then that won't be the worst input anymore because I'll find it immediately. Then the worst input would be one where the peak is in the middle, because then I'd have to go over half of the list to get there. Let's think, what if I just do a binary search? So if I pick the middle element and I look at the left and the right, yeah, I think I would be able to know whether there's a peak on the left or on the right, right? Would I? So if this is low and this is low and this is high, what does that tell me? Let me write down a few things. So, yeah. If this is low and this is low and this is high, or does it say the elements are unique? No, right? No. Low and high is a weird way to say it. Put a bunch of zeros. Wait, I just realized, if everything is a 0 and you have a 1 somewhere, you can't do better than n time. How are you going to find the 1 without looking through everything? I think I have to reread the problem because this doesn't seem possible right now. A peak element is an element that is strictly greater than its neighbors. Given a 0-indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 equals nums of n equals negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in O log n time. Am I wrong, or is that impossible on this input? The only peak in this input is this. Is it in the constraints that it's gonna... Oh. There's no adjacent duplicates. Did it say that, or... It doesn't say that. What? Okay, it doesn't say that, but that's key. That's key. Otherwise, you could have this, and there is no O of log n algorithm that finds the 1 in this. Okay, so there are duplicates, but they're not adjacent. Okay, so, well, What I was going to say is you can think of every number as as 1, 2, or 3, because a 3 is what you would assign to a number that's greater than its neighbors. No, that doesn't make sense, because you can the thing is, I kind of only care about the comparison of the number with its neighbors. I don't care about its absolute value. But I do care when doing a binary search. I'm really thinking that binary search is what we're going to have to do. But you've got the left, you've got the right, you've got the mid. What could you know about these that would tell you which side a peak will be located on? So if this is smaller than the mid, if the left is smaller than the mid, then there may be a peak inside here, but there may not be, because these could all be strictly increasing from the left all the way to the mid. So there's not necessarily a peak if left is smaller than right, than mid. If left less than mid, not necessarily a peak on left side. If left is greater than mid, if the left is greater than the mid, it's the same thing, because now everything might be strictly decreasing. Yeah, everything might be strictly decreasing. So there's not necessarily a peak. Right? Strictly decreasing. That would make the first element in here a peak. Because of the negative infinities, but that's not going to be the case when you're recursing. When I recurse and now this is my list, I can't assume that there's a negative infinity on the right side of this boundary, right? Okay, maybe a better way to think of this is to not care about the left and the right. And to just say, all right, are you a peak in the middle? Middle equals peak. Obviously, if yes, return. If the middle is not a peak, then it might be a valley. So that would mean this is, it goes high, low, high. Peak would be low, high, low. If it's high, low, high, what are we returning? The element of the peak? Return middle. The index of the peak, right? Yeah, return the index into a peak. Okay, so if the middle is a peak, you return it. If the middle is a valley, so it goes up on both sides, then you know there's going to be a peak on both sides. It's hard for me to describe that in words, but if you just picture that on both sides it starts at a graph that starts at the bottom, and then in the middle there's a valley, not a valley, but like it goes down and then back up, then you know. Oh, I guess it could be strictly decreasing all the way to the middle and then strictly increasing back all the way to the top. And then there's no peak. No, there would be a peak. The peak would be the edges, because on the edges you would be greater than the edge side and greater than the side that goes downwards. Okay, so you know that both sides have a peak, so you can recurse on either one. If the middle is like 1, 2, 3, so it's increasing to the right, then you know that there's a peak on the right. Right? This would be so much easier if I could draw a picture, but you know there's a peak on the right if your slope is going up in the middle here, then it either goes up forever all the way to the right side, in which case your peak is here, or it there's a peak partway through and it starts going down at some point. And then if the middle is strictly decreasing, then there's a peak on the left for the same reason. Okay, so mid equals len of nums or let's do it like this. Left wait. This works when there's negative infinity on both sides. What about when you recurse? Once I'm looking here, there's still a negative infinity on one side, but not on the other. So let's say I'm looking here now. And I find that it should be on the left side, which means I am decreasing. Well, it still works because I already decided there's a peak here. No. Let's think about it carefully. It doesn't necessarily work. If I'm here and I'm finding that it slopes down, do I know that there's a peak here? So what did I know about this point? The only thing I knew is that it's not a peak, and that I guess I also know that it slopes up. I do know that it slopes up from here. Otherwise, I wouldn't have recursed to this side. Like, it either fully slopes up, 1, 2, 3, or it goes down and then back up. But either way, there's an upward slope here. So that's the same as if it were on the edge. Okay. So I think this is the way to do it. So mid is, you take the biggest index and you divide that by 2. So left and right equals 0 and len of nums minus 1, while left is less than right. And then here you can just do L plus R over 2, and yeah, just like that, L plus R over 2, integer division, so we end up with an integer at the end. Then you look at the neighbors of mid. So I guess if you're a list of length at least 3, so if len of nums from L to R, well, that's a weird way to do that. If R minus L how about don't go until L is less than R, go until R minus L is equal to 3. How do I make sure that I never... Oh, I know how. I can add a negative infinity to the end and the beginning. Okay, def slope, and you take a index, int. I don't know what you're going to return yet, but if, let's return a string for now. So this is what I want to figure out, is nums of I less than nums of I plus 1. Then you return that there's a if nums of I minus 1 is less than nums of I is greater than nums of I plus 1. Then this is a peak. Otherwise, you recurse either left or right. So let's, if I minus 1 is less than I, if I minus 1, let's say if I minus 1 is greater than I, that means you are either this or you're this, so you can recurse left. if I plus 1, is this exhaustive? Like, do you go right otherwise? There's no other case, right? You're either fully sloping left, fully sloping right, fully a peak, or a valley. Valley can go either way. So if you're high, low, high, then we can just return right. We don't need, we can just, no matter what, we can return right. Because I checked every possibility. So you find your peak, your mid, and then you say slope of mid. Oh, the other thing I wanted to do is consider the boundaries. So if how do I do that? I wish I could just add an infinity on the ends. This is not how you do len. I think I can do that actually. I can just do that. So I can just say nums equals, so from math import infinity, nums equals negative infinity plus nums plus infinity. Negative infinity on both sides. And then I don't want to start at 0 and -1. I want to start at 1 and len of nums negative -2. Because I want to start right before the infinities. Now I know that I can always do +1 and -1 and it'll never fail. I don't need this anymore. Now I can just do while left is less than right. Find the mid, find the slope. If the slope is peak, return mid. If S is right, then we recurse right. So L equals mid plus 1. L if S is left, then we recurse left. So R equals mid -1. Then at the end, you return, you only return L if it is a peak. So you return, so return slope of L equals peak. Oh, and you have to subtract 1 every time you found a peak. And that, what am I doing here? You return L if, so you do if, then return L -1. You have to subtract 1 because I added an infinity to the end. Does this work? Submit. Wow. Look at that. Cool. So this is log n because it's a binary search. We don't look at every element. We have our search space halve. Our search space becomes half as big on each iteration until we find it. So we end up, the search space looks like a binary tree where at each step we go down one path or another. And then in the end, you only had to go down the height of a binary tree. Anyway, because we're having it on each time, that ends up as log base 2 of n. It's weird to have like returning strings here. But it's I don't immediately see a a better way to do it. Like, I think the helper function is helpful, and then I don't like anything else we returned would just be an encoding for peak left and right. So this is as good as you can do, pretty much, with this strategy. All right, next question. Number 163, missing ranges, premium. Easy. You are given an inclusive range, lower to upper, and a sorted unique integer array nums where all elements are within the inclusive range. A number x is considered missing if x is in the range, lower to upper, and x is not in nums. Return the shortest sorted list of ranges that exactly covers all the missing numbers. That is, no element of nums is included in any of the ranges, and each missing number is covered by one of the ranges. So I have lower and upper and a sorted unique integer array, nums. And I know that every number in nums is between lower and upper. A number is missing if it's in the range, but it's not in the list. Exactly covers all missing numbers. Covers is a weird way to say includes. That is, no element of nums is included in any of the ranges. No, okay. Oh, you're returning a list of ranges, not a list of elements. Okay. Okay, return a list of ranges that covers the missing elements. Can you do a range of a single element? Yeah, 2 to 2. Okay. All right, so like first idea that comes to mind, start with a range that goes from lower to upper. For each num in nums, split the range. So we're going to start by saying none of the numbers are covered. And then we're going to look at our first number and be like, except that one. So we're going to split the range. It's going to go from lower to first number, and then from first number to upper. The ranges are inclusive. Inclusive. So it's going to go from lower to first number minus 1, and then from first number minus 1 or plus 1 to upper. And then every time we look at a new number, we figure out which range it needs to split, if any, and we split that range. Would you ever need to merge ranges? No, you only ever split them. You never find out later that you shouldn't have split something. You only ever split them. Okay, so this is the idea. Then we're just going to introduce a whole bunch of bugs and off by one errors and stuff and edge cases and just have to get it working. But this is the idea. So ranges equals a list It's a list of ints. Well, it's a list of tuples of ints. But whatever, we'll use the thing they want. So it's a list of lists of ints, and it starts at lower comma upper. At the end, we're going to return ranges. In the middle, we do for num in nums, split the range, split a range. So the first thing we want to do is find the right range and then split it. How do we find the right range? We can binary search. Because our ranges will stay sorted. So kind of messed up to call this easy when we have to do a binary search. This is going to be an n log n solution because of the binary search. I don't think there's a way to do faster than that. I think you have to binary search, right? You might have n ranges, like at the end of the processing, you'll have n ranges, and you can't just look through all of them because then you get to an n squared runtime. And you can't jump directly to the one you want because you don't have a key into the one you want. You just have a number that's yeah, I think you have to binary search. Okay. Binary search. So given a we can define the binary search out here. Don't take ranges as an argument. Binary search for a number. And it should return a range. No, it should return an index into ranges. Okay, so binary search. You have a left and a right end. You start left at 0, you put right, you start right at len of ranges -1. While L is less than R, I immediately get a plus 20 minutes debuff whenever a problem includes binary search because I'm just so bad at the off by 1 errors. While L is less than R, you either like recurse on the left or on the right, or you found your thing in the middle. So mid equals L plus R over 2. Integer division so that mid stays an index. If ranges of mid of 0, because we're going to be looking for the first, find the first range whose lower is greater or equal to num. So this is the first range that you might be included in. Or, I mean, this is the only range you might be included in. but it's the first range where you're greater than the start point. So this is lower, the first index into the range. So if the lower point of the range is greater or equal to the num, then the thing I want is starting at mid, so left equals mid, and including mid up to right. It has to include mid because greater or equal is the thing we want. If that was the property that mid has. Else R equals otherwise it's on the left side. And because we're not greater or equal, because mid is not the answer, we can also subtract 1 from this, because we've already looked at mid and that was not part of the answer. Okay. Then at the end, if L is the answer, so if ranges of L of 0 is greater or equal to num, or you know what, just return L at the end. And then we can just check out here. So here we can say I, the index that we find, equals binary search of num. We can check if that range is legit. So ranges of I, if num is between the two. So you would say if ranges is less than or equal to num, which is less than or equal to, because we have to check this right side anyway, because that wasn't part of the binary search. Actually, we're guaranteed that, no, we're not. No, we're not. We have to check this right side. One. So if the number is in the range, then we have to split this range. If the number is not in the range, then we don't have to do anything. The ranges are already covering this number. Okay, so how do you split a range? You remove it. You have to reinsert stuff at the right place. Which means I should probably be using a linked list. But I don't wanna. Let's start by not doing that. Let's just do range equals that. You can't call it range because that's a built-in Python thing. So R equals ranges of I. R1 equals R0 num minus 1. R2 equals R equals num plus 1 to R1. So the first range the split first range is this. The split right range is this. If you haven't like split the range into oblivion, so if one side is still greater or equal, if the right side is still greater or equal to the left side, then you insert it back into our list of ranges in the correct spot. So if this is so complicated to do. New ranges is an empty list if R1 of 0 is less than or equal to, because you're allowed to have a range that starts and ends on the same thing, R1 of 1. New ranges dot append R1. And then same for R2. So if R2 is a valid range, then you append it to new ranges. And then ranges from I to I is going to be new ranges. So we're inserting between 0 and 1 ranges here. And let's open up a Python interpreter and see if what I'm doing makes any sense. So let's say some list equals 1, 2, 3. Then list from 1 to 1 is going to be equal to A, B, C. What is list now? So going from 1 to 1 was an insertion after 1. What I actually want is to replace 1. So I would go from 0 to 1. So now 1 was replaced with this new list. Okay. So that means I minus 1. But what happens if I'm talking about 0? So Python L equals 1, 2, 3. L from -1 to 0 equals A, B, C. Then I end up putting it too early. Or sorry, too late. I put it before the last one. But I can't do 0, 0, right? Or I mean 0, 1, because that's going to put it after the 1. Wait, that replaced the 1. That was exactly what I wanted. Okay, so it's not I minus 1, it's I to I plus 1. Alright, now let's try to find all of our off by 1 errors. So we got the right answer for this, which is to do nothing. For a real problem, we got nowhere near the right answer. Well, we got some. I think this worked for 3, for 1 and 3. We did do 1 and 3 properly. We didn't do 50 properly. So why don't we print ranges before and after the loop and inside the loop. Or I guess just inside the loop and after the loop. So we start with 0 to 99. Then when we found the 1, we went from 1 to 99, which is not actually right. We should have started 1 higher. Should have done num plus 1. Oh, no, that was when we found the 0. So that's right. And then when we found the 1, we bumped it up from 2 to 99. That's right. Then when we found the 3, we said 2 to 2 and 4 to 99. That's right. Then when we find the 50, we screw up. We failed to find that 50 goes here. Oh, because I was looking for my binary. Okay, yeah, here's the binary search debuff. The number I'm looking for, I said give me the first one that's greater or equal, but that's not going to give you 4 if your num is 50. So I could say give me the one that comes before the one that's greater than this, but I don't know how to. I guess I could say give me the first one that's greater than this, and then do -1 at the end. Or I could do give me the last one that's smaller than this. Find the last range whose lower is less than or equal to num. So if you are less than or equal to num, then you are on the left side of what I'm looking for. Or what I'm looking for is on my left side. If the mid is less than or equal, I'm looking for less than or equal. So I want mid and find the last range whose lower is less than or equal to num. Find the last range whose lower is less than or equal to num. So if we're in the middle, here, and this middle is less than or equal to num, then I want to look to the right because I want the last one that's less than or equal to num. If I want to look to the right, then L is equal to mid. Since I am less than or equal to num, I include mid. Okay, so does that work? No, because my list never shrinks enough. Do I just need to put a -1 here? And then I want to return R because I want the thing on the right of the range. Okay. Okay, we're getting the right answers now. So let's submit. Ta-da! 0 milliseconds beats 100%. Well, you can't do better than that. And I even had a print statement in there. So this slicing insertion thing is worrisome. This depending on how Python does slice insertions like this, slice assignments, this might take O of n, which means this whole algorithm would be n squared. If we used a linked list, we could guarantee that we're doing these insertions in log n. I mean, these insertions would be O1, and the binary search would be log n, and so this whole thing would be n log n. Python slice insertion complexity. Google AI says it has to shift the existing elements. Okay, so this is technically O of n. Use a linked list to make it O of 1. Should we do that? We're not really going to learn anything by doing that. So let's not do that. Next problem. Number 164, maximum gap, medium. Given an integer array nums, return the maximum difference between two successive elements in its sorted form. If the array contains less than 2 elements, return 0. You must write an algorithm that runs in linear time and uses linear extra space. So O of n, O of n. Okay, so the obvious answer is to sort the list and then iterate through the list and see what's the maximum gap. That would take n log n because sorting the list takes n log n. We're trying to do this in O of n. What's the maximum difference between two successive elements? So how can you possibly do that without starting by sorting the list? That's crazy. My instinct says you can't, but obviously you can, so let's think about it. The maximum difference between two successive elements. How? How can you possibly do that? So for each element, you'd have to know what its successive element is in order to calculate its difference. I guess they did say we can use O of n space. But even if we're like, how would that help? Oh, no. No, how would that help? So if we did something like we had a hash map that let us find, like, okay, what we need is we need to be able to iterate over nums, and at each element quickly jump to whatever its successive element is. The problem is the way I just described it is not possible, because if you could do that, you could sort the list in... Well, no, I guess you can't necessarily sort the list. You would just know all of the successive elements, and then you'd still have to sort the list after that. What kind of data structure could I use to jump to the successive element? Like I have 1 and I want to jump directly to 3. Like I could use a, I don't know, even if I had a sorted list, that's not easy. I'd have to binary search in the list, which would put me at n log n. So maybe you can't just jump to the sorted element, or to the successive element. Maybe there's some way to... Okay. So something that I'm thinking right now is, let's say we have a 1 in the list and we have a 1 billion in the list, and the list is length like 5. We know there has to be some big jumps in there because there's not enough elements for the successive elements in that to be small, to have like low differences. We can find the min and the max and the average in linear time, but all that tells you is that there are big jumps. Like if we think about the last problem, we could think of like, okay, go through the list and find the min, go through the list and find the max. That's still on time O1 space. Now that we have the min and the max, do the last problem. So make a range that starts from lowest to and goes to highest. For each element in here, split the ranges. The ranges tell you which elements are not in the list. And then at the end, return the biggest range. That would give you the right answer. It's very suspicious that this question comes right after the last question, but our last answer was n log n, so it doesn't work. It's so interesting, though, that you could apply the exact thing we just did, but it's n log n. I guess that makes me wonder whether there was a way to do better than n log n. Probably not, because we ended with 100% 0 milliseconds. But now I wish I had looked at the solutions. How would you do it better than n log n? You'd have to find the range you're looking for without doing a binary search. I don't know how you could do that. It's just so suspicious. It's so interesting that that last thing could literally apply to this. Because once you have the ranges, you just have to iterate over them. That would take linear space. The thing that comes after the like iterating over them to find the maximum one would take linear time, but constructing the ranges would take n log n. So how can you find the max consecutive difference in linear time? We know we're going to have to use O of n space to achieve it, otherwise it wouldn't have said that. So even with using a bunch of space, how would I get that to be linear time? So if it's not jump from the thing to its next successive thing, what else could you do? Like, as you're iterating over this, what else could you access quickly? And then that would tell you the maximum difference between two successive elements. Like, finding the successive element would work. I don't know what else could possibly work. This feels really hard. It's the fact that it's labeled medium means we must be missing something. Because it just feels really hard from here. You can't find the successive element in O. You can't match each element to its successive element in O of n. You'd have to do some kind of sorting in order to be able to quickly find the element that you're looking for. If you can't find the successive element fast enough, how are you going to find the maximum difference between two successive elements? Like you can find whatever you want in O of n, but then you can't find the best one in O of n because you have to find all of them, which would mean n squared. I'm so stumped. Why don't I write down a few of my stray thoughts? So you could sort, then iterate over while calculating max diff. That's going to be O of n log n. Another O of n log n. Why don't we try some n squareds for each num. Find its successive element. Calc max. Or yeah, that part's obvious. O of n log n. This would be generate the ranges of missing numbers, return the largest range. Use solution from last problem. We got any other n squareds? There's a different n log n is for each element binary search to find its successor. Which also requires pre-sorting. So that's like n log n in two different ways. We had a fragment of an idea that was like range based. That's like, you know, there's some big jumps if the min and max are far, but that doesn't lead to anything helpful. We can find min and max in ON, which also, I'm not sure how that helps us. How do you do this? How do you do this with linear time? You have an unsorted list. You want to find the maximum difference between successive elements in its sorted form. You can't sort it. I don't know how to say anything about successive elements in an unsorted list in O of n time. This might be the most stumped I've ever been on a Leetcode problem. Two successive elements in its sorted form. So if the last problem had a linear time solution, it would fit perfectly. That would give you the answer. No, the last problem, was it sorted? I don't. No, the elements weren't sorted in the last problem. Or they wouldn't have to be, not the way we wrote the algorithm. But I just don't see how you could do the last problem in linear time. You have to iterate over each element that's being used to split your range. And you would have to do each of those in O of 1 time to get the whole thing to be linear, which means binary searching for the exact range that you're looking for is not fast enough. What's going to be faster than binary searching? If they were giving you the elements in order, then you could do it, because then you could avoid binary searching and just know that you're on the end of the list of ranges. But they're not. The list is not sorted. The list is not sorted. I just, I don't know where to go from there. You can't split the ranges. You can't find the range that you need to split faster than log n. Could you do it without finding the range that you need to split? No. How could you? How could you? Um, like, I'm still thinking of range-based ideas. Like, you get a 3. You start with 3. Then you get a 6. The largest difference is going to be 6 minus 3. Then you get a 9. What you have to do is you have to find the number closest to 9 that you've seen so far. It doesn't matter if it's greater or smaller. It just needs to be closest. So for each, is there some data structure you could have that lets you find the closest number in O1? I think that might not be enough information to sort. Would it? Because like, let's say the thing I'm thinking is what I'm asking for impossible? It would be impossible if what you want, if you could use it to sort a list in O of n time. So let's say we have a data structure that you can build in linear time. And whenever the thing you can do is say, give me the closest number to this. You can insert into the data structure in O of 1, and you can say, what's the closest number to this in O of 1? Could you use that to sort a list? So you have an unsorted list. For each number, you could find out what its closest number is. And then you would just check if that number is less than or greater than it, and then you would put it before or after. I don't immediately see how that would let you sort the list, because if you put it, like, let's say we have 1, 2, 3, 7, 8, then I would and let's scramble it so that it's like this. So 8, you put it in. 2, you say what's the closest number, and it gives you 8. So you say, okay, then I'll put 2 before 8. So now you've got 2, 8. Then 3, you want to say what's the closest number, and it's going to say 2. And then you'll say, cool, I'll put 3 after 2. But you don't know if it should go before 8. You actually do know that, because you know that it's closer to 2 than anything. It's closer to 2 than it is to 8. So it would have to go between 2 and 8 on the side closer to 2. 7, you say, what's the closest number? And you'll get 8. So now you put the 7 before the 8. 1, you want to know what's the closest number. It'll say 2, so now you put the 1 before the 2. So I guess it does let you sort. Unless I'm missing something. Like, one of the things I'm assuming is that you can quickly find the 2. But you could, because you could just have a hash map that points into the linked list that you're building. Okay, so it can't be that there is a data structure that lets you find the closest element fast. That can't be it, because if that was it, you could use that to sort a list in linear time. Like, is there some example that I'm missing where this would fail? I don't think so, because closest element means you know it's going to be adjacent to this, and you just need to put it either before or after, depending on the size of it. Okay, so it can't be that there's some data structure. Here's what's impossible. A data structure with O1 insertions, O1 find closest element. So if you can't do this, and you can't do any of these other things, then it's going to have to be something like, instead of finding all of the differences and returning the maximum one, it's going to be something that you can do to the whole list that will give you the maximum difference. But it would only give you the maximum difference. It wouldn't give you every difference and then you find the maximum out of it. So is there a data structure that keeps track of the maximum difference and then has O1 insertions, O1 find maximum difference? The problem is you would have to keep track of all of the differences to do that, because when I insert a new element that splits the maximum difference in half, you have to know what was the next maximum difference. Like, the only thing I can think of is the last problem, where you start by saying there's no maximum difference, and then you add an element to it, or you add two elements, and now the maximum difference is the difference between those two. Then you add a third element, and now the maximum difference is either you've split the range, either you've split the difference, and the maximum difference is some fraction of what it was before, or you inserted something that's distant from both ends, and the new max difference is the distance between an end and this thing. But every time you add a new thing, you have to keep track of all of the ranges to know what the new maximum difference is. You have to keep track of all of the differences. If you're keeping track of all of the differences, you're going to be running in n log n. Unless there's some way to do it without binary searching, which I can't imagine there is. Some way to find the range that you want to split without binary searching. The only way to do it without binary searching would be to request things in a certain order so that you already know where they're going to be. Or to have some kind of hash map, but you can't use a hash map if the thing you're looking for is a number close to the thing that you have stored. Like this thing still seems like the only way you could do it, but we've already proved that it's not possible. You can't do this. You have to use log n. You just have to binary search. Why do I keep proving this problem is impossible? It's clearly not impossible. It's not even hard. It's a medium. Return the maximum difference between two successive elements in its sorted form. I'm just sitting thinking silently because I am just kind of out of ideas, but let's when I look at this, how do I know what the maximum difference is? I can kind of tell that there's a cluster above 7 and there's a cluster around 1. And I just need to find the distance between those two clusters. So, like, that would lead me to some kind of algorithm where when stuff is close together, I merge their ranges because I only care about the farthest away stuff, the stuff that's farthest apart. Like, I don't need to keep track of the fact that 1 is 1 away from 2. Once I know that it's like stuff around 7 and then stuff around 1. The only so it's something like do the range thing from the last problem, but you don't need to keep track of as many ranges. Because you can merge stuff if it has literally no elements in between, or if the distance between the stuff is smaller than the distance between other clusters. So you kind of, maybe you only ever have 2 ranges. The problem is, like, let's say we start filling in the gaps. Like, the next elements after this are 4, 5, 6. Then the small differences between the stuff inside these ranges will matter, because then this gap will go away. So it's not like you can just forget about the distances that are small, because they might end up being the biggest distance once you're done looking at all the rest of the elements in the array. Yeah. Can there be duplicates? It doesn't say there can't. So let's say that I had this array, right? The biggest gap here is between 8 and 10. Let's add 11 in here too. So everything is 1 apart except for 8 and 10, which is 2 apart. How would I find that? I think what I'm doing in my head is sorting first and then seeing where there's a gap, which would be n log n. I'm basically checking, is there anything missing between 1 and 8? So I go 1, 2, 3, 4, 5, 6, 7, 8. No, nothing's missing. But you can't do that. How would I find this gap without sorting? Okay, here's an interesting idea. If we find the min and we find the max first, that's O of n each. Now we know that every single time we insert a new element, so like now our list is 1, 11, and then the rest of them without 1 and 11. We know that every single time we add an element from now on, we'll be splitting our ranges. So we start with these two. Our max difference is 10 right now. Every time we add a new thing, our max distance is getting smaller or equal. It never goes up. That feels significant. So then we take a look at the 8. That splits our range, and it tells us that our new it tells us that our new biggest distance is between 1 and 8. But we're not allowed to just forget the distance between 11 and 8, because maybe everything that comes after this will split the 1 and 8 distance so much that the distance between 8 and 11 is the answer. So let's say we remember both ranges, 1 to 8, 8 to 11. Now we're adding a 2. That's going to split the 1 to 8 range. How did we know that? We basically had to find where 2 fits in this list of ranges, and that's going to take log n. If we remember all the ranges, then to find which range we want to split has to take log n. If we don't remember all the ranges, it doesn't. But if we don't remember all the ranges, then the subsequent elements could come in an order that screws us up. So could we remember something other than the ranges? I don't see how, because you kind of need the range information to figure out what the new max distance is going to be once you include another element. We're over 45 minutes, so I've failed this job interview. I've written 0 lines of code after 48 minutes. That's not a good sign. um, okay. No. Well, okay, I'm having an idea. Is there some kind of 2-pointer thing? So if I start one pointer on either side, and I shrink one or the other, depending on which one would give me a bigger gap. Could I do something that ends me on, or it doesn't necessarily end me on the biggest gap, but where I would have considered the biggest gap by the end of it? I don't think so. I don't think something like this would work, because the stuff could be in an order such that it screws me up and it makes me miss the gap that would eventually be the biggest gap. Because what would you even do? Like, so the gap between 8 and 6 is 2. Incrementing this one will give you a bigger gap, but then I'll already be missing the true gap, which is between 8 and 10. Right now I'm just iterating between the different types of solutions to problems that Leetcode questions have. So like recursive, dynamic programming, 2-pointers, binary search. So is there any kind of dynamic programming? Like if you knew the answer, or recursive, if you knew the answer for this, if I knew the largest gap in this range, and now I'm saying add a 6 to the or in this subarray, and now I'm saying add a 6 to the array. Is there a way to know the largest gap now? No. Not from just the knowledge of the largest gap. I also have to know what in here is going to be closest to 6. Or something along those lines. I need to know something more. Um, because the thing you would need to know how 6 changes the answer is the ranges or something along those lines. How long should I bang my head against the wall before writing an n log n solution and seeing before giving up, basically just writing something that I know is n log n and then seeing what people's solutions were? I don't like to do that. I really want to solve all of these myself. I think in the past when I've done that, it was usually by accident. I thought what I had was optimal. I don't like submitting something that I know is not optimal. I'm just really stumped here, and I've been stumped since the beginning, since like 10 minutes in. I said all of the ideas that I've been repeating. Is there some other dynamic programming? Is there some kind of 2D array that I could store? Well, it can't be 2D because then I would be using more than linear extra space. Is there linear extra space I could store? Well, you could if the if you have something recursive with where the start point is always the same, then you could use the endpoint of the array as your index into the dynamic programming table. But that's the question, is what could I know about this that when I add 6 to it, I would be able to figure out the answer in 01 time. And the thing I think I would have to know is what's the closest element to 6? But I can't pre-compute that because I don't know that 6 is going to be the thing that I'll need to know about. Because given a list, I can find the closest element to 6, but it's going to take O of n time. So if I have to do that for each element, that's going to be n squared. I can do it in n log n time, or I can find the closest element in log n time. If I have some pre-processing done, but even then, if I have to do if I have to do something that takes log n time n times, that's going to be n log n. So I have to find the closest element instantly, but we know that that's impossible. Because then you could use that to sort any list in O of n time. So what else could I know about this other than the closest element to 6? I don't know. I don't know what I could know about this that would let me find the answer other than what's the closest element to 6. Yeah, I just don't know. I don't know how that could be. I don't know how this problem can be possible. That's what it boils down to. I haven't thought of an idea that could even be possible. Because you have to do it in linear time, which means at some point you have to answer the question of, once we are a certain amount into the list, what do we do to get one more into the list? Like, every linear time algorithm boils down to that. I have the partial answer up to a certain element. How do I add the next element to my partial answer? And I just can't think of anything that you could possibly do to combine a partial answer with a new element fast enough that wouldn't also let you sort the list. I'm going to be so pissed if there was just some obvious way to do the last problem that solves this problem. Or, I mean, that runs in O of n. I just don't know what it could be. I haven't been able to think of anything that wouldn't also let you sort a list in O(n) time. It's not like there's not like extra constraints I didn't consider, right? The numbers are just numbers between 1 and a billion, and there's up to 10,000 things in the list. We can't do anything of the form split the list in half, find the answer on the left, find the answer on the right, and combine them. Because anything that's like that will get us to n log n. So it does have to be something where you have the answer for the list excluding 6, and then you combine 6, and now you have the answer for the whole list. But you can't, the thing that you're storing can't be a data structure that lets you find the closest element to 6. It can't be a list of the ranges covered, or, you know, the ranges not covered, like the distances between numbers. Because in order to find which distance you have to split, you'd have to do log n work, time. Return the maximum difference between two successive elements in its sorted form. I'm just racking my brain to think of how can you have a partial solution. Like, what could I know? What could I know about a partial list where I could find the answer by adding a new element? The range splitting thing is still the only idea that I have, and it's n log n. Same as just sorting the stupid list and iterating over it. The thing I'm trying to think of is there some way to do the range idea but not have all of that information. To have like a little less information than the full list of ranges, just enough to know what's going to happen when you split. But I don't see how you could do that with any less than the full list of ranges. I'm just trying to think through that. It's also hard to think of stuff that uses linear extra space other than the range thing. I'm really stuck on the range thing. I wonder if I hadn't done the previous problem before this, if I would have just thought of this question differently and wouldn't have gotten stuck on trying to fit a range solution into this. Because what do I learn every time I add a new element to my consideration? Um, if the closest element to this new element is farther than the next closest, then this is my new maximum difference between successive elements. But every time you add something, the thing that would make it your new maximum difference is if it's farther on the right than all of your stuff is close to each other, it's farther on the left than all of your stuff is close to each other. Or if it splits your current maximum difference and now your new maximum difference is not necessarily part of the thing you split. It could be a different difference. But the problem is, if it could always be a different difference, then you have to remember all the differences in case you start splitting them one at a time. The only way to prevent splitting them one at a time is if you do some pre-processing to the list so that you're always adding stuff away from the cluster. But you can't do that pre-processing because that pre-processing would allow you to sort the list in linear time. Like if I could do that pre-processing in linear time, I would be able to use the pre-processing to sort the list in linear time. So if my pre-processing is I'm always able to grab an element which is either greater than my greatest or lesser than my smallest element, then I just put it at the head or tail of my current list, and I'm constructing a sorted list as I go. So it can't be that. So let's write that down. Here's another thing that's impossible. Pre-process the list. So that every element is greater than the greatest so far or lesser than the smallest so far. In O of n in O of 1. You can't do that. You would, if you did, you could sort a list in O of n. But it would be nice, because then you could solve this. Every time you consider a new element, you don't have to worry about it splitting your ranges. So you never have to store your ranges. You just have to store the top end and the bottom end. But yeah, we can't do it. So what else could we know about this so that when we add the new element, we can figure out the answer? It can't be the ranges, it can't be the closest element to 6. So does knowing the farthest element help you? I don't think so. No, I don't think so. Yeah, this is the most stuck I've ever been on a Leetcode problem. We got to number 164 before becoming truly stumped. I've spent more than an hour and 20 minutes on previous problems, but usually I'm making progress. I've never spent an hour and 20 minutes without a single line of code. There's some insight that we're missing, obviously. But there's some insight that's so simple that the whole problem becomes medium. Um, hmm. Just trying to plunge my empty brain for insights. Go, generate an insight now, please. Um, it really seems impossible. Like the longer I think about it, the more I'm like, there's nothing I could know about this that would give me the answer that's not already one of the things I've proved is impossible. Like, there's got to be some crazy trick that's like, you sum everything together and then you take some modulo and that gives you the answer. Like, obviously that makes no sense, but I'm just saying, like, something so different from what I've been thinking about. Does summing everything together give you anything? That would tell you the average distance between elements. Right? It would tell you you don't even need to sum them all to do that though. If you just find the min and the max, that gives you an upper bound on the distance between anything. Does summing all the numbers do anything? What would it tell you? I'm just trying random stuff now, but what would summing the numbers tell you? If the numbers are all really close to the minimum and you have one like a trillion in there, then that's pretty much the same thing as just finding the max. Whereas if the numbers are concentrated around the max and you sum them, you know, that tells you that most of the numbers are around the max. If you look at the difference between the sum and the max. Could it tell you exactly which side of the middle the largest distance is? I don't think it can. Because it could tell you how many are greater than the middle and how many are smaller than the middle. But the two problems with that is we already know that anything that's about considering about having the list is going to give you a log n in your runtime. That's the first problem. The other problem, I forgot my train of thought. Because let's say we want to do something around splitting the list in half and computing stuff about each half and then combining the answers. If the combining step takes O of n time, then the whole thing will be n log n. So we can't do that. If the combining step is O of 1, then the whole thing will still be n log n. No. If the combining step is O of 1, then I think the whole thing is log of n. No, it can't be log of n because you still have to consider every leaf node. And there are n leaf nodes. It's only if you don't have to recurse on one side that ends up being log of n, because then it's the height of the... You just do one thing per height of the tree. So it would still be n log n if I have to do O of 1 work on each merging. Is that right? That doesn't seem right, because shouldn't it be less than... Yeah, I guess that is right. It would still be n log n. So we can't do anything around merging. Like, there are some ideas I can think of with merging around, like, No, it's not going to matter. If you can merge, you should be able to add a single element to a big list, and we just can't think of a way to do that. Because if I have a sorted list of my existing gaps, that's the same as solving the previous problem, which is n log n. Adding this will either create a new gap, which would be fast. That would be O1 because it goes at the beginning or at the end of the list. Or it splits one of your existing gaps. And then you have to... that means you have to remember all the other gaps to know which one is now the biggest, but it also means you have to find the gap that you're looking for, which would take log n time. Okay, so if we know the min, the max, and the median, if the median is less than the difference, than min, if the median is less than min plus max over 2, then we know there's more on the left side than on the right side. But we could have just counted to figure that out. So we can, in O of n, I mean. So in O of n, you can figure out which side has more elements. That doesn't tell you which side has bigger gaps. Our numbers are positive or non-negative. I just don't see how you could do this without storing the ranges as you go. Every time you add a new thing, you check what it splits in half. Or not in half, but what it splits. But that needs n log n. There's no way around the fact that that needs n log n, I think. So you have to find which range it's splitting. I don't think there's a way to find which range it's splitting in O of 1 using some crazy hashing stuff or pre-processing stuff, because I think that would let you sort the list. I'm not sure about that, but because you're maintaining a sorted, I guess in this idea you wouldn't be maintaining a sorted list, but you would be maintaining a list where you can always find a sorted list of ranges, but you would be maintaining a list of ranges where you can always find which one something is included in O of 1, which makes me think that's the same as having it sorted. But I'm not sure if that's true. Is there just some way to do this in O of n? I'm tempted to look at the solutions to the last problem and see if somebody was able to do it in O of n. Because I could have looked at the solutions already. Like, I do allow myself to look at other people's solutions after I've solved the problem. So here's some other observations. The answer is going to be less than, you're bounded by min of nums, max of nums minus min of nums. The biggest difference possible would be the one where the smallest number is as close as it can be to the biggest number. On the other side, we can bound the answer the other direction too. The answer must be bigger than, let me just say max and min instead of doing that. What am I trying to say here? It's something like, if I know that there's 5 numbers, and the distance between them is 1 billion. The distance between the min and the max is 1 billion. Then my answer can't be smaller than 1 billion over 5 over len of, let's just do over len. Because the farthest that they could be is if they're all evenly spaced. This doesn't help though, because it doesn't actually tell me what the answer is, and the bounds could be really, really loose. Okay. Is this the first trick question in Leetcode? Should I just say there is no solution? That's probably it, right? I can find the average distance between numbers. That's what this is. Right? It's I think that's right, that this would be the average distance between numbers. I'm just trying to think of how you could arrange them that where it would not be the average. So like if you had 1, 2, 3, 4, a billion, then the max distance between numbers is between 4 and a billion, and the average distance is uh, like 250 million, because a bunch of them have a distance of 1 and one of them has a distance of a billion. Whereas if they're all exactly a quarter billion away from each other, then the average distance is also equal to this, to a billion minus 1 over 4. So we can easily find the average distance between successive elements in its sorted form. We didn't need to store extra space for this either. This is the average distance between successive elements. This is the max distance between non-successive elements. I don't know. I don't think this really helps yet. What else can we figure out by looking at the whole list? I don't know. I don't think there's anything that helpful there. I'm really struggling on this one. In this example, every subsequent element is greater or less than the every element we've seen so far, which makes it looks easy to do because 3 to 6, the difference, the answer so far is 3. 6 to 3, or 3, 6 to 9, the difference is 3. Because you can just keep track of the left end and the right end of what we've seen so far. One comes before everything we've seen so far, and the distance is 2. But when you have an example like this, what can I remember in the intermediate that would help? We know I can't pre-process the list to make it be in an order like this. We know that because that would let us sort in O of n. Yeah, that would let us sort in O of n for sure. Because we would just build our list out from wherever we started, and at the end we would have a sorted list. But yeah, I'm back on what can we know about this list so that when you ask me what's the maximum difference between 2 successive elements in this list and in this list, I can tell you the answer. I just cannot think of something that wouldn't also let you sort the list. But I've said that a million times already. The range splitting thing is the other idea, but I think that is firmly an n log n answer. I just don't see how you're going to find the list to split in less than log of n. At some point, I have to throw in the towel. I can't be on this question the rest of my life. I don't think 2 pointers can ever work because the list is not in any kind of order. There's no reason why at the end of our processing our 2 pointers would have ever been on the pair that is successive and maximum distance apart. So I just don't, like, you'd have to pre-process the list in a way where you're guaranteeing that, but I don't know what way you could guarantee that other than sorting the list. I'm going in circles. I'm bouncing back and forth between there's nothing I can know where I can add something that doesn't let me also sort the list versus I can remember the ranges, but then that's going to be n log n also. Everything I can think of is either equivalent to the last problem or lets you sort the list. Because it's so tempting to say, like, I have a 6, find the thing closest to 6 that I've seen so far. And if its distance is greater than the greatest we've seen so far, then that's the new maximum difference. But we know that that's not possible because if you could always, if you had a way to do this, you could sort the list. Why is there randomly an impossible problem labeled medium? I can't know what the closest thing to 6 is, and yet I have to find the maximum difference between 2 successive elements. If 6 was if it caused me to have a new maximum difference when I added 6, then I would know the distance between I would know the closest element in the list to 6. I would know it because I could figure it out from the fact that my maximum difference just increased. If my maximum difference just increased, that means 6 is the farthest element from the rest of the list, from the element that has the maximum difference between its successive element in the rest of the list. I would know the distance between 6 and the closest element because that would be my new maximum difference. And then I only have two things to check: 6 plus diff and 6 minus diff. One of those two things is the closest element in my list to 6. So if I just had a set at the same time, I could check which one it is. So if I was able to, if every time I added a new thing, it was the maximum difference, then I could sort the list. Because every time I add a new thing, I would learn what its closest element is, and we already found that if you could do that, you can sort a list. But that's only if the list is in a certain order to begin with. If I add an element and it wasn't the max, then I have to not learn anything. If I can learn what its closest element was, I can sort the list. So how could I learn nothing when the new element is not the maximum difference element? But learn everything when it is? Like, what could I know that would tell me that? What could I know where now I can figure out the max difference, but I can't tell what you were closest to if you were not the max difference? How could I not tell what you were closest to in one case, but yes, I could tell in the other case? Like, I'd have to store some weird data structure where I only know the max difference and I don't know really a lot of the structure of the rest of it. So what could I be storing so that now that you give me a new element, I know the max difference, but I don't know the difference between it and its closest thing? I don't know the difference between it and its closest thing in my list. I just know that it doesn't change the max difference. So I guess I could find a difference between it and something that is less than the max difference. I don't have to find the closest one. If I just find any that's less than the max, then I don't learn what the closest distance was. So for each new num, find any diff less than current max. You have to do this in O one time somehow. If you can find any difference less than the current max, if you can find any difference less than the current max, that means your current max is unchanged. If you cannot find any difference less than the current max, that means your current max must shrink to be, or I mean grow to be the distance between this and its closest thing. Wait. Shouldn't the max be shrinking? If you can find any difference. So my current max here is 2. When I find that 6 is 1 away from 7, I know that my current max is not changed. So yeah, I guess in this way of iterating, your current max always shrinks. Okay, so can you find any difference smaller than current max in O of 1? So if you just go through the list and find the first difference less than current max, that might take O of n. If you have some sorted array, which you're not allowed to have already, but even if you did, then it would take a binary search on it, which would take log of n. So already with cheating, we're only at log of n. How can we get all the way down to O of 1? And we can't find the closest element to this because, yeah, like whatever we do, it can't also tell us the closest element to this. It has to only tell us that one exists or does not exist. I don't know. It's just, it seems impossible. like it really seems like you have to store the ranges. Nothing else will tell you all the answers you need. I'm gonna crash out. They put an impossible problem in my Leetcode. I'm just gonna sit here thinking silently for like another 4 hours. Find any difference less than a certain amount in O of 1 time. It really seems impossible. You can do it in O of n time on an unsorted list. You can do it in log of n time on a sorted list. Oh, wait. No. A diff is like new element minus existing element. Absolute value of that. So the thing I'm starting to think of now is current max is something you know before you get to 6. So it's something you can use to maintain your data. Like what I'm trying to think of is like, can I put all the things less than current max on one side and all the things greater than current max on the other side, and then quickly check when we get a new thing because we know which side to look at? But we can't because the numbers are not less than max. It's the difference, or yeah, the nums, this is the stuff inside our data structure. These are not less than or greater than current max. It's the difference between between this, but I'm reinventing sorting now because the other thing I was going to say is you can do it in both directions. So instead of doing an absolute value, you store a data structure like this, and then like the other way to say that is you inverse these. So minus num, plus existing, and you flip the direction of these. So the last thing I was going to say is get rid of this part. But I'm just inventing sorting. I'm saying get rid of this part and then just imagine that your whole data structure is offset by 6. But yeah, I'm just inventing sorting again. You wouldn't get O1 anyway. It would still be log n. Existing minus num, existing minus num. How would I know if this is the case? Well, if any of them are greater than the current max, it would be the largest existing. And if any of them are less than the current max, it would be the smallest existing. But how is that possible? Because wouldn't... And that you could do in O1. You can remember the current largest and smallest, but wouldn't that only make sense if your 6 is not splitting the range, right? I think I got confused here. This, because the thing I want is absolute value of existing minus num is less than current max, right? It's, or if it's greater than current max. So I can't just take the absolute value off. Can I? Maybe I can. But I can't just remember the min and max so far and the greatest distance so far, because that just doesn't tell me what I need. Because the 6 might be really close to, like my min might be negative a trillion, or might be 0, and my max might be a trillion. And the number that my 6 might be like 500 million, which could be only 1 away from some other number, which would mean it is not my new max difference. So this doesn't work. I can't just get rid of the absolute value and check both sides. Because it would have to be the same existing number. That's the problem. It has to be the same existing number in both of these. So I can't just take the min for one and the max for the other. And I can't find what the existing number is either. That's the other really tough restriction to meet. I can't learn what the existing number is, otherwise... No. I can learn a existing number that satisfies this. I can't find the one that most tightly satisfies it. Otherwise, I could sort. But to know whether or not a number satisfies this. But how could you know that? You just have to keep the ranges and check which one 6 is closest to. You have to. How else could you know in the abstract that it's that there exists a number close to 6, but not know which one? Because that's what I need. I need to learn. I need to know that there's a number close to 6, but not know what number. So if I knew that 6 is the number I was going to have to compare to, then every time I add a number to my list, I can check how close it is to 6. And then just remember Well, no, because then I would learn what the closest number to 6 is, which I'm not allowed to know, lest I have an algorithm for sorting in O of n. But I can't think of a data structure where you could learn that you have a number close to 6, but not learn which number it is. Something I'm thinking right now is the resolution that we care about is the current max. Like, we don't care how close it is to 6. We only care that it's closer than current max or farther than current max. So if you subtracted current max from all of the numbers, and you could do that in advance, let's say. Current max, put the minus on that side, greater than 0, put the minus on that side, less than 0. Let's say we pre-process, we had these numbers. We had a list with all of these numbers. Is not sorted. Every time we add a new number, it goes into our list. We subtract current max from it and we put it in our list. Then given a new number, can we figure out if there's any existing number like this? Like this is the thing we actually want is absolute value of existing minus current max minus num. Is less than 0. Less than, well, this is less than num. No. Existing minus num is less than current max. This is wrong. This is wrong. Let's try to write it again. So you have this. One of these would be positive. One of these would be negative. So the negative one is like that, with a plus here. For the same existing. Why am I having so much trouble thinking about absolute value? Find if any numbers in our data structure so far, the difference between it and the number we're looking for is less than current max. And to do that in O1. You can't. Like, I'm just spinning my wheels. You can't, and the problem's not possible, and that's the answer. I got down the rabbit hole too deep on this. I don't even think this would give the right answer if you did this anymore. I want the maximum difference between two successive elements in its sorted form. This is going to give me like the minimum distance or something. All right, I'm going back into the think tank. I'm in the think tank and I'm spinning in circles. Swimming in circles in the think tank. I keep having the same thoughts in a circle. Like jumping between ideas where adding a new thing to an existing thing, if you could do it fast enough, you could sort in O of n, and remembering the gaps, which or the ranges of the gaps, which you would need log n in order to find which gap you're splicing. I just don't see a way around either of those two facts. I also don't see how you could do any kind of dividing and conquering without introducing a log n into your runtime. Really seems impossible. I don't know what to say. It just seems impossible. Like, it's not like they forgot to told me that it's sorted. The question would be trivial if it were sorted. Can I expand these things? Is this cheating to know that bucket sorting is applicable? I mean, bucket sorting integers that are bounded is a way to cheat and sort in less than n log n. But I think that's cheating. I don't think that could be the answer. Because then the solution would just be sort it and then find the smallest gap between successive elements. And you could do that. It's just that I don't think that's what they mean by linear. You know, it would be linear if the size of the integers are constant. But you could say that for any Leetcode problem that involves sorting. Um, but how else could you use bucket sort to help you here? I guess if I have, no, that's not it. I was going to say if I have this and I'm looking for the closest element to 6, then I could bucket sort this, where like stuff that's really far away from 6 gets dismissed, but that none of that makes any sense. I could just go through the list, O of n. If I'm going to be bucket sorting, which is already O of n. So the bucket sorting would have to be as like a pre-processing step. Like if it is O of n, you have to do that before you start iterating. Or after. I don't know what you could bucket sort that would help this. These topics might just be wrong. Because it would have said in the problem statement something about how the size of the integers is constant. If the way to get it to be linear time is to bucket sort. So, something else I'm thinking is that you could do like an approximate sort, possibly. Like if I sorted it, but I didn't get everything right in the sort, but I did get like all the small things come first, all the middle things come next, and all the big things come last. Would that help me find the maximum difference between successive elements? would it? Like what? I'm not being very precise, but like if I pre-process by sorting, then I can very easily find the max difference. It's go between each two successive elements and keep track of which difference was biggest. If I had it kind of sorted but not fully, like is there a way to have it kind of sorted where I can't so easily find the answer, but I can still find the answer? So what's if stuff is really close together compared to the distance that stuff gets in this list, I don't care about their order. I only care about the order of stuff that could potentially be the maximum difference. I'm not sure if that helps. Let me write this down though. Idea. I only need the list to be so sorted, sorted enough that the maximum difference between successive elements that the elements with max distance, that the successive elements with max distance are like end up next to each other. That's not quite right because I might mistake a different gap for the max gap. Unless the other gaps are small enough. I'm having trouble formalizing the thing I'm trying to say though. I think there might be something to this idea. I just need to figure out a way to phrase it in a way that makes sense or that is like rigorous. Because it like if I have if this stuff is not super well sorted, and then I have like these that are not super well sorted, that's pretty helpful. Because it's the clustering thing that I was talking about earlier. Stuff around 7, stuff around 1. it's pretty helpful because then I don't have to worry about within the cluster. I just have to worry about the distance between the clusters. So really all I care about is that these are numbers between 1 and 3. And these are numbers between 7 and 9. You know, I'm kind of doing this range thing again. But maybe if I do it in order, I can not have to look at all of the ranges. So if I can sort in a way that gives me something like this, then I can convert that into ranges. I guess the problem is, how do I know that my max difference isn't within one of these? Well, I guess I'll have to define my ranges such that you go into the bucket based on your based on what am I trying to say? You go into the bucket based on whether your distance would be big enough, whether your distance is small enough that I don't care what it is. But you might end up with one cluster per number if all of the distances are similar. And then finding which cluster to put the next number in will be hard. Unless they're like kind of sorted, then finding the next cluster shouldn't be hard because you should always be in the cluster to the right. But how would you even do a kind of sorting? Like I'm trying to think of something along the lines of, you do a bucket sort where the size of the bucket is proportional to the max difference that you've seen so far. The idea being, you want the max distance to be between buckets, not within a bucket. So now the thing I'm thinking is similar to one of these ideas I had earlier, where let's say let's say I make 10 buckets. I don't know how many buckets to make, but let's say I make 10 buckets. And you go into a bucket based on like the min is over here, the max is over here, and the buckets are evenly spaced. So the buckets are of size min plus max over 2. Or not over 2, over number of buckets. So I was thinking over 2 earlier when I was trying to decide, do you go left or do you go right? So you have this, then you put all your numbers in the buckets. So here, I just need spaces. Then you look at the counts of your buckets. So if the distribution looks something like this, then you know that the answer is going to be here, like the right? Because the answer is going to there's a huge gap between the smallest in here and the biggest in here. Do we have a bound on the number of elements? It's huge. So it's not like we can say make 1 bucket per element. Not that that would make sense, but like make half as many buckets as there are elements or something, so we can find a big gap. Because that's too many buckets. I think we might be getting somewhere, or we might be getting nowhere. You can tell where the answer is. How do you tell where the answer is? You start from left and you go right and you find gaps. Wherever the longest gap of buckets is, that's where the answer is going to be. If you have a bunch of evenly sized gaps, then it's harder to tell what to do. Like, let's say you ended up with 1 in each bucket. Then you have no idea what your answer is. The only way to avoid that is to have more buckets than elements. More buckets than elements. But if you had as many buckets as elements, what am I trying to say? No. Yeah, if you had as many buckets as elements, that would be O of n space. If you had as many buckets as elements, then you would guarantee some empty buckets, but you don't guarantee that the empty buckets come between anything, because you could, oops, you could still end up with, here, I'll use this, with everything in one bucket. So that doesn't help you either. Or you can end up with half, well, no, that wouldn't matter. But yeah, you could have everything in one bucket. And the only way to prevent that is to have one bucket per, like, 2 to the size of the integer. So one, to have 1 trillion buckets here. I'm so confused about whether bucket sort could even in principle help. I knew 20 minutes into the problem that this was going to take me hours because I just have no leads. I still have no leads. I don't know how I'll be able to finish in the next hour, for example. So with this bucket sort thing, either it tells you the answer right away because there's empty buckets between filled buckets, or you end up with a degenerate case where either everything is spread, all of the buckets have stuff, in which case we don't know what to do. We'd have to look into each bucket. We could prevent all of the buckets by prevent all of the buckets from having stuff by using as many buckets as there are elements, or like 1 more buckets than there are elements, which would still be O of n. Then the way the answer could elude us is if everything ends up in the same bucket. If that happens, we can recurse into that bucket and do it again. The amount of times we'd have to recurse is log base number of buckets of n, which means this would be n log n. It just would. That would be an n log n algorithm. We just cannot escape the ghastly specter of n log n. So what would an answer that looks like that would be like all of the elements are one apart from each other. And there's different ways that we could recognize that. So we could it's not like that's impossible to notice without using n log n time. You could notice that in O n time by finding the min and the max and seeing that the average distance between stuff is 1. That tells you that the actual distance between stuff is 1, because that's also the minimum distance between stuff that is possible. But yeah, it could be that it's not exactly 1. It's like there's a bunch of 1s and 2s. And 1, 3. There's one thing that's 3 apart somewhere. Or even they're all 1 apart except one thing that's 2 apart. How could you figure that out quickly? You could do the range thing. Right? If you did... No, not exact. Well, not necessarily. The reason I thought you could is that you would end up with only one range in the end. So you'd avoid the log n problem of binary searching for the correct range at the end. But it could be in an order such that you get a lot of ranges first and then you eliminate them one by one. But yeah, this is the clustering idea. It's you do a bucket sort, and then you can tell that the largest in this bucket minus the smallest in this bucket, that's your difference. That's the max difference between successive elements. You can tell that if you can tell that because this there's an empty bucket, which means the distance between anything in this and anything in this is larger than the distance within any bucket. So this kind of works. This kind of gives you the clustering. The issue... Actually, hold on a second. I forgot that you make the range start at min and end at max. So you can't have buckets. You can't have empty buckets like this. You'll have to have something in the beginning and something in the end. So this is not possible. This is the worst case, and you can avoid it by having more buckets than elements. I think we finally got it. I think we finally got it. So O of n is bucket sort with more buckets than elements. Iterate over buckets and find largest gap. And you're guaranteed to have empty buckets, and empty buckets is going to tell you the distance between the buckets is what's going to tell you the answer. Oh my God. All right. Okay, so number of buckets equals more than len of nums. So len of nums is already, okay, len of nums plus 1. That's how many buckets we want. Then let's define our buckets. Buckets is a list that has within each bucket, we just need to know the min and the max inside that bucket. So it's a list of tuples int. And we need a lot of these. Wait, how do I also want to know if they're unpopulated. So it's a min and a max, or it's none. And then we're going to have none. We're going to have num buckets amount of none. Okay. Then we're going to populate our buckets. So for num in nums, well, we also need the min and the max first. So, but we can just do that in Python. Min of nums, minimum, maximum equals max of nums. For num in nums, you figure out which bucket you're in. So the way you do that is num if you're equal to the minimum, you go in the first bucket. So it's going to be num minus minimum. And then you should divide by the number of buckets. No, you divide by the number of buckets so that you because if num is the maximum, then you should end up in the last bucket. So that's what this will do. Divide by the number of buckets. This is which bucket you go into. So I equals this. Buckets of I, like if not buckets of I, then buckets of I is going to be equal to num, because it's the minimum and the maximum. Elif, or else, buckets of I is going to be equal to whatever's smallest between num and buckets of I of 0, and whatever's largest. Oh, I wrote this wrong. This goes inside the num. And whatever's largest between the max and the endpoint, or the between num and the max, the existing max. So that gives us all of our buckets. Then we can iterate over them. Best equals 0. We know that there will be empty buckets. That is guaranteed. So we just want to find the one with the biggest number of empty buckets, or all of our candidates are ones that are between empty buckets. So start last at, I don't know, none. Then for I in len of buckets, which is also called num buckets, but I can just do len of buckets. If buckets of I if it's not none, then this will become the last bucket. Last equals buckets of I. I only actually care about the max in here. So buckets of I of 0. Of 1, I mean. If I have a last, then I want to compare, then my best is whatever is better between my current best and the distance between buckets of I of 0 minus last. Then at the end you return best. You have to do range. No way. I'm sure I'm off by 1 somewhere. Like my division is not quite right, or I should have. I think like because I'm rounding down, I think there might be an edge case where. Because num buckets is exactly the minimum I need to make sure that I have empty buckets. Although come to think of it, I don't actually need empty buckets. I do kind of need empty buckets. I need the max distance to be between buckets and not within a bucket. But that could happen when all of your buckets are filled. As long as there's only one element in each bucket, actually, then that will happen. So this I think will work. No. Oh, I'm never doing maximum. I have to make sure that I is between minimum and maximum. So I think I have to divide here. Okay, I'm getting a little confused. I have to divide by maximum. Then this will give me a number between minimum and maximum. Like not a number, but an index between minimum and maximum. but I didn't put num buckets in this equation. Don't I need num buckets? This is an index. This, I guess, if I don't integer divide, this is how far am I between minimum and maximum. How far am I between minimum and maximum? That's what this is. And I want to rescale that. Hold on, that's not what this is. Okay. So we've got a range. This is the min, this is the max, and then there could be other stuff. And I have some number in here. So I have num buckets, and they're supposed to store stuff in here evenly. I want to rescale this range so that 0 is this. So I can do that by subtracting minimum. So when I subtract minimum, I have this. But now I want to stretch this to the right. I can do that by multiplying by like I want this side to be 1 basically. So how do I rescale this side to be 1? I divide by maximum. Then maximum will be 1 and everything else will be in between. Okay, so now I have a number between 0 and 1. Here I want to multiply this by num buckets. And then let's just take the floor of that. Division by 0. If my biggest number is 0, then everything will be in the same bucket. But also if my biggest number is 0, I know that there is no gap, so my answer will be 0. So if maximum equals 0, return 0. Okay. Index out of range. So how can I be rounding, or I must not be doing this. This equation must not be right yet. So it seems right, like you subtract minimum from your number. So that pushes you here to the left. If your number was 0, you would be 0. You divide by maximum. So if your number was 1, or if your number was maximum, now you are 1. And then you multiply that by the number of buckets, so that if your number was 0.5, now you are, and there are 10 buckets, now you're bucket number 5. I might just be off by 1. Like end rounds down though. There's no way that I is 0, right? Or -1. What if we printed it? Print I, print len of nums, and print len of buckets. But it's not, it's not stopping on the one that I want to stop it at. I can't tell which one's wrong yet. How about if I is greater than 9,000, then do it. So I ended up being len of buckets. So you may need a -1 here to make sure that you don't end up on the index that is like after the end of the list. We're getting somewhere. 43 test cases passed. This one output 0. So these are all off by 1. I definitely shouldn't be saying 0. I should have 3 buckets, and they're all in a separate one. And my max should be the beginning of this bucket minus the end of the last bucket. So what's going on? Print buckets. Let's see what I end up with as my buckets. It should be length 3. It's length 4, which is okay. Everything ended up in the same bucket, which is wrong. And why did everything end up in the same bucket? It must be that this formula is wrong. So, like, let's consider this number. This number should not show up in the first bucket, but you take this number, you subtract minimum from it. So now this number is going to be 2. This number is 2. You divide that by maximum. This number is going to be, well, maximum is the huge number. I actually want to divide by the difference between maximum and minimum, because I wanted to divide by 2. Maximum minus minimum. And it's if maximum minus minimum is 0. So if there's no difference between the largest and the smallest, then you don't have to do anything. Okay, we did it. This is more buckets than we needed, possibly. Or actually, I'm not sure. I think there might be a case where oops. I think even though I passed all the tests, there might be a case where everything ends up in a separate bucket. No, that would be okay. As long as everything is in a separate bucket, that's okay. Because then when you iterate over, you'll find the right thing. Don't print the buckets. Yeah, that's it. That's the answer. I'm trying to just quickly see if I can do it any faster. I don't see a way to do it faster. I think all of the steps that I'm using are required. Yeah, I need the min and the max in each bucket. I'm very curious as to what the people on this side of the peak are doing. But I'm in this lower peak down here. And man, was it hard earned. This was the hardest problem I've ever done. I can't believe it was rated as medium. All right, let's get our ego crushed. Let's look at the solutions and see how there was some really simple way to do it. N log n, cheating. Okay, and then they had a new solution with buckets. Yeah, that's what we did. Previous max also. Exactly what we did. How does someone end up with, like, what was that other peak in the, yeah, how do you beat 92%? Oh, you just cheat. If you cheat, you can get it faster, because then it's not algorithmically faster, but in practice it's faster because you get to do the sorting inside C. Okay. All right. So we probably did find the best. I mean, I know we did find the best solution, but because it's ON, but we probably found the best implementation also. That was crazy. That was crazy. That was so hard. But we're not done. Number 165. Compare version numbers, medium. Given two version strings, version 1 and version 2, compare them. A version string consists of revisions separated by dots. The value of the revision is its integer conversion, ignoring leading zeros. To compare version strings, compare their revision values in left to right order. If one of the version strings has fewer revisions, treat the missing revision values as 0. Return the following. If version 1 is less than version 2, return -1. If version 1 is greater than version 2, return 1, otherwise return 0. This is so easy compared to the last problem, which was the hardest problem we've ever done. I've ever done. Okay, I mean, you just like honestly, you just do version1 equals version1 dot split and convert each piece to an integer. Tuple int of piece for p in this. Version 2 is the same, but version 2. And then you return version 1 less than version 2. This will literally solve it. Oh, you split, obviously you split on period. That's what I meant to do. And then actually it may not work when the version strings are different. I don't know why this doesn't work though. The value of the revision is its integer conversion, ignoring leading zeros. Why does this? Yeah, version 1 is smaller than version 2. Oh. You're supposed to return a like if it's smaller, return -1, else return 1, or elif. It's larger, return 1, otherwise return 0. And then you're supposed to treat the the missing versions as zeros, or the missing pieces as zeros. So so if len of version 1 is less than len of version 2, while version 1 equals version 1, it's a tuple that starts with version 1 and then also has a 0 on the end. Do the same for the other side. Now technically, oh, you can't construct tuples like this? Well, I can just convert it to a list. And then convert the list to a tuple. So technically, I don't want to do that because then I'm creating all these new tuples, which could take O of n for each one. So instead, I'm just going to be appending 0. Keep it as a list, plus equals 0. And then convert them to tuples here. Version 1, version 2 equals tuple version 1, tuple version 2. Zero milliseconds beats 100%. So it may look like I'm cheating a little bit by using built-in Python stuff. I'm not really cheating though, because I'm not doing the I'm not hiding the complexity, basically. Like I'm doing the stuff that is part of the solution in Python code, in my code. and I'm delegating stuff that is like trivially delegatable to Python. It's not like it asked me to sort something and I called Python sorted. So like I'm calling split, which is the first thing you could accuse me of cheating for. But you can easily, like obviously easily, this is O of n, and you could easily implement it yourself by keeping a list, and every time you encounter a period, adding the value that you've been constructing so far into the list. And then and casting it to an integer. Then this, I'm not hiding any complexity here. I'm just adding more zeros to whichever side's smaller. This is no complexity. I'm just converting my list to a tuple. Here is where you could say I'm hiding more complexity. I'm using the fact that Python tuple comparison already compares from left to right. But you could just replace this with a loop that iterates over the list, and whenever the first element it encounters that isn't equal, you'll return -1 or 1. I said that in a weird way. Then the last thing I'm thinking, in order to cheat even more, is this is returning a Boolean, and then I have to convert it to -1, 1, and 0. But I think there's a Python built-in way to do that already. So if I open up Python, there's something like operations.compare or something, or like integer.compare.cmp. If I do 1.cmp2, a equals 1, or a equals 1, a dot cmp2. There's no such thing as dunder cmp. Is there not, though? I thought there was. Maybe that's a Python 2 thing, because it has less than, but that's going to return a Boolean. I thought there was a way to get whether it's less than, greater, or equal in one shot. But I'm thinking, I'm trying to remember this. I'm pretty sure there's something you can import from the standard library that will convert a Boolean comparison like that into a less than, into this CMP thing that I'm thinking of. Python CMP. CMP to key. So CMP was part of Python 2, and I'm pretty sure there's a way to get it in Python 3. The functools total ordering decorator to automatically implement the remaining rich comparison methods if you have equality and less than defined. Well, I don't want the rich comparison methods. I want CMP, but CMP to key is a thing, right? Where is it? Key. I have seen this. I have seen this. CMP to key. Functools CMP to key. No, because what I want is a CMP. I want to get a CMP out of non-CMP. Python CMP, Python 3 CMP. This may not exist. How to use CMP in Python 3? You can define it yourself. Okay. So A greater than B minus A less than B. If they're equal, then this will be false, false. What's false minus false? I guess that counts as 0 minus 0, and it gives you a 0. Otherwise, one of these will be 1 and one of them will be 0, so you'll get either 1 or -1. That's cool. So let's code golf this a little bit. Return, I want to call them v1 and v2 if I'm going to be doing all this arithmetic. So v1 greater than v2 minus v1 less than v2. I got slower. I also want to call all of this stuff v1 and all of this stuff v2, just for conciseness. Is it actually slower, or is it just oh well, this one needs to still be called version 1 and version 2. Is it actually slower, or is it just the variance of Leetcode? Oh, can't change that. Yeah, it's not actually slower. It's still good. Cool. Yeah, you're not going to do better than that. Both in conciseness and optimality. So there it is. All done for the day. Thank you for watching. If this was helpful, please leave me a like on Leetcode and on YouTube. That's all. Peace.